Okay, welcome to Computer Science E75. For those of you playing along at home, we just did introductions, so welcome to you all nonetheless. This is Building Dynamic Websites, and my name is David Malin. I will be your instructor this semester. Hopefully the first day is now a little less awkward, and if you come back next week, you'll at least see at least one familiar face. And tonight is all about introducing one, the course, and two, the domain in which we're going to be playing all semester, namely that of dynamic websites. So it's perhaps worth starting with the opposite of what the course is all about, static websites, which is where one typically begins making the simplest of web pages. Static website would mean whipping something up in this thing called HTML. And per the course catalog, presumably all of you have at least some background in HTML or at least some general familiarity with website development. But this course is ultimately going to be, as you'll find, more about programming and more about taking input and producing output. And we as a course will care much less about the aesthetics of what you produce in terms of the graphics and the beauty. And we're not expecting works of art in terms of design on aesthetically, but rather programmatically underneath the hood. So with that said, the course is definitely a lot of work. You will find that even though the course is structured along the lines of 4 assigned projects and 1 final project, for each you'll have 3 weeks, you'll find that each does take a non-trivial amount of time. We typically tell people that a project should take over the course of 3 weeks, maybe 10 hours per week, but it's fun time, to be honest. Presumably you're taking a class like this because you like coding, because you like doing website development, and so, thank you very much. And so hopefully it will be time well spent and spent with great fun. So we're going to start the semester off just by getting folks up and running with various accounts. I actually found one, so I'm all set, but thank you. I guess Gabe relayed the message. We'll start the semester, as you'll see, with just getting some basic building blocks in place. We'll spend the first few weeks of the course introducing some fundamentals, and it's with projects 1, 2, and 3, 0 indexed, that you'll really get your hands dirty implementing some fun dynamic websites, and we'll touch on those just a little bit tonight. So if a static website is about HTML and GIFs and JPEGs and all of this that doesn't really change unless you, the human, intervene and update the website, well, what does it mean to be dynamic? Well, it typically means, and it certainly means for this course, that you're using some kind of programming language. So HTML, XHTML, CSS, these are certainly not programming languages because you can't really implement logic with them, conditions with them, looping with them. They are, as one of them is called, a markup language, more about aesthetics. We'll focus in this course on this framework, which is really more of a buzz phrase than anything, called LAMP, Linux, Apache, MySQL, and PHP. And I say it's more of a buzz phrase than anything because all 4 of those technologies existed long before someone realized you could string them together and make this acronym. Sort of like DHTML, if you're familiar with that one, which meant nothing other than that you used JavaScript, CSS, and HTML on a web page. And now we call it DHTML. So LAMP is what this course focuses on in great detail, but the underlying technologies, and then also AJAX. And AJAX, as you may know, AJAX, whether all capitalized or not these days, is about implementing even more seamless user interfaces. So with AJAX, can you do websites much more akin to Google Maps, for instance, which was kind of revolutionary a few years ago when, in contrast to Yahoo Maps and MapQuest, you could click and drag and move the entire map, and we were well past this 1990s approach of clicking the up arrow, the left arrow, the right arrow, the down arrow. Many of you probably use Facebook or use various banking sites, or any of the most popular websites today use a little or a lot of AJAX, and thus JavaScript, which we'll also focus on in the course, to create much more interesting user interfaces so that when a user clicks a link, less often do they see this entire reload of the page, a big white blinking screen for a split second, and then that new content. And so some of these technologies are interesting, I think, not only because you can implement these more seamless user interfaces, but we're also living in a world now where, ironically, bandwidth is, again, limited, and screen size is limited, and the fewer bits you can send down the wire, and the more logic you can push to the client, the better off the user experience is going to be, again, as well. And I think, don't quote me on this, but I think the latest iPhone has like a 600 megahertz processor. That's a lot of cycles that you can put to use. And fortunately, things like Safari on the iPhone and other browsers on BlackBerries and other phones, Android, they have this capability of executing client-side code. So you'll find that this course is ultimately about a lot of server-side development, at least in the first half or so of the course. And then by the second half of the course, we begin to keep using server-side elements, PHP and SQL and MySQL and other such things. But we also then introduce JavaScript and some client-side programming. So more on the specifics of those projects a little bit later tonight. With that said, let's try to tell the story from typing in a URL, hitting enter, and actually getting back some results. Because what you'll find in this course that we try to do is not just say, here's how you implement X, but also talk a little bit about why X works the way it does. And when your own code breaks or there's something wrong between points A and B, well, what might be the explanations? We'll try to take more of a soup to nuts approach so that you'll actually be sniffing your own traffic, at least at the HTTP level, looking at the headers, going back and across the wire, looking at the specific parameters, looking at the cookie values, things that a typical web developer might not necessarily care about or even know about. And we'll expose some of those underlying details. We'll make use of entirely free and for sometimes open source software, which will be a huge gain in terms of productivity. One such example that I'm a huge fan of, and which we will push, if only because it makes your life, the developer, easier, is a little plugin, if familiar, called Firebug for Firefox, which allows you to see what the browser is seeing and even change things on the fly. So hopefully you'll exit this course not only with a good conceptual and practical foundation in the words in the course's catalog description, but also some really useful tools that are available for the most part for Windows, Mac OS, and Linux alike. So I sit down, or I'm a typical user, I sit down at a browser window, I type http://cnn.com and hit enter. So what happens then? The end of the story is the day's news comes up. But what are the several steps before then? I hit enter. Can anyone fill in one of the first blanks here? And there's many ways to begin this story. Yeah?
Tries to figure out the IP address of
Okay, good. So every server on the internet has what we will call I'm stalling as I sift through for a piece of paper. Every computer on the internet has what is called an IP address. This is a numeric address of the form x.y.z.w, where each of those letters is a number from 0 to 255 with some constraints. And just like a U.S. postal address uniquely identifies a building, 33 Oxford Street, Cambridge, Mass. 02138, so do these numeric strings uniquely identify, small white lie, computers on the internet. But unfortunately, CNN.com is not sufficient information for your computer, for your browser, for your operating system, or the nearest router, big fancy hardware device that actually gets data from point A to B to figure out where in the world CNN is. So there's this duality in the internet between host names, aka fully qualified domain names, and IP addresses, and we've got to map one to the other. And as an aside, what you'll probably find tonight, and maybe occasionally throughout the course, is that because people in this course have such diverse backgrounds, sometimes I'm quite sure some of the material will be a bit of review, but what we hope to do certainly is to at least fill in the blanks for those of you coming at the course with a bit more background, and then also acquaint everyone every day with a little something new, at least. So we hit enter, and my computer, CNN.com, needs to know what that host name or what that fully qualified domain name maps to. So who does my computer ask? Where does it get back this answer called an IP address? Okay, so there's these things called DNS servers. So let's continue this story. So DNS, domain name system. There's a whole bunch of servers out there on the internet whose sole purpose in life, for the most part, is to translate these host names, these human-friendly strings, to IP addresses and back. So right now I'm on Harvard's network. I hit enter, and my computer has presumably been configured by me, by a special DHCP server, by a system administrator to know what Harvard's DNS server's IP addresses are. So these are some servers on campus that just have really big tables, sort of a very large spreadsheet with at least 2 columns, IPs in one, host names in the other, and it just does lookups in that. So I hit enter. This asks the nearest web server, what is the IP for CNN.com? Hopefully it knows the answer, because then I get back some packet, and it informs Mac OS and my operating system, oh, the IP is 1.2.3.4, and you know what? Why don't you remember that for at least a few seconds, few minutes, few hours, so that you don't have to bother me again. And that's called caching. So now my computer knows the IP address of CNN.com. What next happens? Okay, so it rewrites this just human-friendly string with an actual address, and if you think of my computer as sending data like sending an envelope in the mail, what it essentially is doing is constructing like a virtual envelope, so to speak, piece of paper in our real world. It puts in the to field of that envelope that IP address, 1.2.3.4, and you can probably guess in the top left-hand corner of this virtual envelope, it puts what? so my own IP address, whatever that happens to be, so that when this envelope is then handed in a virtual sense to the nearest router somewhere in this building or somewhere in Harvard Yard, it ultimately can inform the recipient how he can contact me back. Hence the return IP address. And so I hit enter, I get back the IP address from the DNS server, my computer then sends a new packet out, this time destined for 1.2.3.4. Well, what happens then? Well, odds are CNN's server is not on Harvard's local network, because otherwise, in the simplest scenario, that packet could just go to the nearest hub or switch, devices that may be familiar to you, and then via a direct Ethernet cable or equivalent, just gets handed to that server. And it can be done all very efficiently, and that's what we would call a LAN. But that's clearly not the case here. So it turns out there's a whole bunch of middlemen in this story, these things called routers, aka gateways. So Harvard's got a bunch of these, and some pretty big ones. This thing, my computer here knows about the closest one, so to speak. So if you've ever run ipconfig on your computer or ifconfig on a Mac or a Linux box, you've seen perhaps what not only your IP address, but also your default gateway. Well, that's just the nomenclature for the nearest router. The router your machine has been told to contact in the event the destination server is not on the local physical network, connected directly via some switch or hub. So my computer hands this packet off to that nearest router. That router itself, much in the spirit of DNS, has its own tables, but these tell it not about DNS mappings, but rather if a router probably has multiple Ethernet interfaces or equivalent, one goes this way, one goes that way, maybe East Coast, West Coast, North, South, anything like that. Well, his tables tell him out what interface should he next send that packet so that the next router can then deal with it. So these routers pass the buck, so to speak, but hopefully in the direction of the actual recipient. And typically there's fewer than 30 hops, so to speak, fewer than 30 routers between points A and B, and that's typically advantageous because with each hop comes a little bit of latency, a little bit of slowdown because there needs to be some computation there. So we can actually see this. We can see my data reaching someone like CNN.com. Let me go ahead and try connecting to a server to which I have access. I'll blow up the font in just a moment. Not that one. Let's try a different one. All right, let's try another one altogether. Did he disconnect my cable? Oh, there we go. All right, so this is a little server to which I have access. Credit for the clever or unclever name is the result of a friend's choice, not mine. But Malin Rouge is the name of this particular server. The reason I'm jumping through this hoop here is because Harvard actually firewalls off what are called pings, sort of low-level packets that you can use for network diagnostics and also bad purposes. So I have to get out of Harvard's network to simulate this. So the astute will realize I'm kind of faking now the story we're telling, but assume that what I'm on right now is my own Macintosh. So I'm at a prompt here. What I'm going to do is type traceroute CNN.com. And what I see here is, that's not working, is it? Let's try web.mit. Oh, it seems my own server is firewalling right now. All right. Let's see how many different servers I can connect to. All right. Okay, there we go. Whew. Saved. Had such momentum there for a moment. Okay. So a whole bunch of data just flowed past, and it may or may not be interesting to us in this context, but let's see what we can infer from some of it. So it looks like some bad stuff's happening. So very often, if you're running tests like this, which you can actually do tonight at home on your own computers, depending just slightly differently on your operating system, sometimes some routers, some servers just say, you don't deserve this information, I'm not going to send these packets along. So that's kind of what's happening there. So unfortunately, our story is breaking down a few hops away, 14 hops away in this case, but let's at least see how far along in the story we get. So at the top here, notice that I have mention of this, traceroute to CNN.com. All right, and this apparently is the IP address of CNN.com, and some DNS stuff happened that was induced by this program called traceroute. Well, now, in row 1, represents the nearest hop, the first router, so to speak, that is between me and my destination. So here in row 1, this guy doesn't seem to have a name, but I know it's owned by Harvard because most of Harvard's IPs start with 140.247. something. So that's kind of interesting there. The next line, number 2, is core something GW. GW probably being gateway. This is just common nomenclature that you begin to notice in various places. So that's apparently the router to which the first router is connected. So one of his Ethernet interfaces goes this way or goes this way, and at the other end of that line is the second router. Well, let's see where if the story gets a little juicier. Well, this seems to be, say, on the border of Harvard's campus. I'm inferring from the name. It looks like Harvard at some point peers, or Harvard peers with someone who peers with Quest.net, a fairly large backbone, an internet ISP. These guys aren't really telling me much of anything after that, but this one's a little interesting. EWR, where are we? Where is my data right now? Yeah, it's probably in Newark, New Jersey. EWR being the airport code for Newark Airport. So a convention out there by sysadmins everywhere is often to use the local airport code as part of the name of your router. Just a convention, but I'm guessing that is in fact a router that's 7 hops away, but in New Jersey. Now notice at the right-hand side, besides the IP address, are a whole bunch of millisecond counts. Well, what traceroute does, much like ping, if you're familiar with that command, is measures the amount of time it takes for data to get from point A to B, or from point A to intermediate hop before B. So what this says here is that it took 13.949 milliseconds to reach Newark, or it tried it again a second time. The second time it actually took 14 milliseconds. The third time, just over 14 milliseconds. So traceroute by default does these checks 3 times, just in case there's an anomaly. It doesn't want you to read too much into it. Yeah?
Are those times cumulative for all the hops up to that point, or is that just the time from hop 5 or 6 to hop 7?
The latter. So these are not cumulative times. This is the time from point A to intermediate hop. And it does it again and again, always originating from your hop, from your location. All right, so hop 8. So this is rather interesting. It looks like, San Jose. There's probably a San Jose other than the one in California that I'm familiar with, because in fact it got there faster than it did to go to New Jersey. So I'm not quite sure what this is. And in fact, if the next hop is Newark, odds are there's not a routing problem where we're going from here to here. So odds are this is just San Jose, New Jersey, if such a thing exists. Level3.net, though, is a little interesting because I know that, too, is a large internet backbone. So again, these are the big fish out there on the internet, the backbones that are all interconnected, that are helping our data get from A to B. Well, then we're on step 10. I'm still in Newark. Looks like data eventually reaches Washington in hops 11 and 12. And then below that, I see some more Washington. Finally, my data gets somewhere in Atlanta. And then, unfortunately, someone clenched their lips, and they're not telling me where the data is actually going. So let's try another one, just to see if we can get a little deeper into it. Let me go ahead and try, let's say, Stanford University, which I know is, in fact, in California. So I'm going to go to www.stanford.edu and hopefully get a bit of sense of what's going on between East Coast and West Coast here. So it looks like, for whatever reason, Harvard slows things down up there. Looks like there's some Internet 2 going on, which means we're probably getting some decent performance between Harvard and there. Now here, Stanford's getting quiet, but at least by 16 hops, we got to Stanford. So let's see how we got there. So scrolling back up, I start off, it looks like at the same path. So this isn't unreasonable. The data is flowing from me out of Harvard by the same path this time, though that's not prerequisite on each time. It looks like I'm then connecting to, at some point, Knox.org, the Northern Crossroads, this very mystical name for just a really big peering point where all these different ISPs interconnect in the Northeast. That we go through a few routers there. Then the next city seems to be what? After the Knox. Looks like Washington, D.C. Below that, maybe? Atlanta, Houston, Los Angeles, yeah, probably in hop 11 there, LOSA, and then LAX, yeah, seems to confirm that we're in the LA area in hop 12. HPR, LAX, I recognize Oak for Oakland, perhaps, so now we're going north in California, and then eventually we are, in fact, reaching what is probably Stanford's own campus. But something happened this time that didn't happen last time. What's interesting about some of the values on the screen now, in contrast to last time's numbers and values? So it's more, right? The numbers you see, at least at the bottom of the screen, are noticeably bigger. Remember, I was talking in terms of like, what was it, 14 milliseconds, give or take? Now the numbers are up at 90. What explains that? Has the internet gotten slower? No, it's just, I mean, it's literally farther. So granted, data or light or electricity, whatever, travels at the speed of light. And yeah, that's true, but there's a lot of things that slow it down between here and there. Among them, these hops, these routers. And this isn't just necessarily electronic propagation delays. They might be bumping up into people who got to that router before them. So if you're really into this kind of stuff or find this interesting and decide at some point to take a networking class, there's a whole bunch of juicy material in the realm of network queuing and router queuing, where you have to figure out what kind of traffic should get pushed through a router first. Maybe we should give priority to people who pay more, to voice traffic. Whole bunches of interesting topics come up. But for us, we just know that it's taking longer, but it looks like at least hop number 11, probably a bit of an anomaly, because odds are something happened there, it got congested, or the router slowed down, or something happened, because that one there, row 11, took 283 milliseconds, which is a noticeable anomaly. And in fact, the other two tests did not seem to work. Maybe the router was just not giving us much data back. But 90 milliseconds to get to Stanford. So now this is bigger, right? This is 4 or 5 times bigger than the previous values. But my God, we just traveled 3,000 miles in 90 milliseconds, getting some piece of data, some piece of email, some ridiculous instant message all the way across the country. It's still pretty neat. Yeah.
Routers refused at some point, so they didn't respond.
Okay.
So what would be the difference between that and a web request? Does the router know that this is a web request? We should give you the page. If this is a trace route, sorry, I'm not giving you that information.
Good question. So the fact that we're seeing some asterisks here and thus some dead ends, at least for this program, does that not mean that web traffic would also hit that wall, or emails? Probably not. So ping, the ICMP is the name of the protocol that traceroute and ping actually use to talk to intermediate hops in this way. And a lot of system administrators simply disable that protocol so that they filter out that type of traffic, but not web traffic, not email traffic. So we'll actually talk in a future lecture about some of these networking layer details, because it actually is relevant even to website development. When we talk about security and SSL, we'll talk about the difference between this number called this number of 443 for SSL versus 80 for HTTP. And so that too is related. You can have per service filtration. So what these guys are doing somewhere along the line is filtering out these ICMP messages, which is not uncommon. And again, even Harvard tends to do it on much of its network. So hopefully we could still in fact get through to Stanford, because they're not blocking, say, port 80 traffic, TCP. All right, so let's do one more test just to see frankly, how neat it is, how fast and yet how relatively slow it takes for data to get from point A to point B. We did CNN before, we did Stanford. Why don't we go to cnn.co.jp, which I believe is the fully qualified domain name of the Japanese version of CNN's website. So let's go ahead and hit, let me add a www just to be safe, and enter. Seems to have resolved. In fact, there is the IP address of it. We have this delay that we seem to keep having, and then, getting interesting, okay. So, how did we get there? Well, looks like, even though we can't see some of the hops, and some of these routers don't even seem to have names, it looks like we did get to the LA area pretty fast. But tell me, what exists physically, presumably between hops 10 and 11, if you can see these values? There's something in the middle that's slowing it down. Okay, yes. So yeah, it's the latter that's, I think, the really interesting thing. There's a really big body of water between LA and the island of Japan, and that's presumably what's slowing things down, is the sheer distance or any of the electronics inside there. But notice again, we're going from 1 millisecond to 10 milliseconds to 80, 70, 183 all of a sudden, a twofold increase over one hop. And it's not an anomaly because it persists in lines 12 and 13 and 14. So we're actually seeing the same delay and again. It's probably some great distance. Yeah. So that too is quite possible. There are transatlantic and transpacific cables. There are also satellites that come into play sometime. It's tough for us sort of here on Earth to know, but could be one of those certainly. Yeah.
21 different steps for it to go. How it doesn't use the landline accelerator modems?
Can you rephrase?
Like it doesn't have the same types of servers as that one.
Oh, so you're seeing different results?
Yeah, completely different.
So that could be for a couple of reasons. One, you're technically on a different network right now, since I connected to a server in the computer science building across campus, which might actually have a first different hop. And Harvard's got a lot of networking equipment, so you might just be exiting the campus in a different direction. Could just be random chance. So routing tables, routing rules do not have to send two subsequent packets down the same path. One can go this way, one can go this way, and eventually they'll hopefully reach the same place, but they don't need to follow the same path. So the short answer is that's to be expected sometimes. But if you do it again and again, or if I did it on the same network, we'd probably see with high probability the same results. Other questions? Yeah?
What is the last exclamation X mean?
The
same as ta.
You know, that's a good question. I do not know. I've never noticed that until now. And either I hit it accidentally on the keyboard. Nope, it's consistent. I don't know, to be honest. So for the curious, if you go home tonight and would like to play with something like this, if you have a Linux box, the command is traceroute. If you have a Mac, the command is traceroute. You just have to open a terminal. If unfamiliar with terminal, you'll become so in this course. Just use Spotlight and search for terminal, or it's in your utilities folder. In Windows, they ever so slightly cut corners. It's called traceRT. So don't finish the word, it's just traceRT. Which is ironic, because usually it's the Unix people who do that, but in this case, it was the Windows folks. Yeah?
You mentioned something about Internet 2 we saw recently. Is that the same thing as IPv6?
No, so that's different. So Internet 2 is essentially an interconnection of universities typically for research purposes, faster connections that were meant to be used not for, say, downloading music and things like this, but rather moving data around between researchers and such. So a lot of universities partake in that. IPv6 is the sixth version of the Internet Protocol, IP. So that too, long story short, we said every computer before on the Internet has an IP address, a number of the form x.y.z.w. Each of those values is a 8-bit value. That's why it's from 0 to 255. So if you've got 8 bits, 8 bits, 8 bits, 8 bits, total of 32, that gives you how many possible IP addresses in the world? Quick math. 2 to the 32, which is give or take 4 billion. So that's a lot of IP addresses, but turns out not enough, right? Much like we were short-sighted as humans with the little Y2K problem, same deal here. There's so many devices now on the Internet, whether it's computers and laptops and cell phones and other electronic devices, and just large entities that already own big blocks of IP addresses that they are free to manage themselves. The world is running out. And if you Google around for this too tonight, you'll find that some people have these dire predictions that we're going to run out of IP addresses in 2 years, for instance. And that may very well be the case, but there are ways to mitigate this. But one of them is for IP version 6 to finally get rolled out. And I remember taking a networking class in 1997, and we talked about IPv6. And here we are again all these years later, now finally really talking about IPv6. IPv6 for our purposes means that you're going to use new addresses that are not 32 bits, but 128 bits, which are huge, right? Not quite as large for the staff as Harvard's 33-digit billing codes, but still very large. And 2 to the 128 gives you a hell of a lot of addresses, which I'm sure at some point we'll run out of, but that's meant to be a solution to a different problem. Per person. So we'll see if we finally get ahead of the curve.
I have a similar question, just staying within Harvard. You said everything starts 140.247, which leaves you now with only a 999, webpage.
And not quite, it's 255. So 0 to 255 is the range of values for each of those placeholders. But still. Your
web address was ampersand something, I think your last name. So the question is, how does it know that you're wanting this particular page out of Harvard or out of CNN or out of Yahoo or whatever?
Okay.
When if everything starts 140.247, it would seem you've run out of numbers.
Okay, so
I mean,
sure.
I'm not sure if I got the right right number. You understand my question?
I do, and let me answer part of the question now, and then we'll answer over the course of tonight the rest of the question. Short comment is, for the folks who didn't quite hear or those tuning in at home, if we only have these two placeholders, x.y.z.w, that Harvard has its own discretion over, that's 8 bits plus 8 bits, so that's 16, that's 2 to the 6. So Harvard has 65,536 IP addresses, and technically we have 128.103. But still, that's a lot fewer than 4 billion, for instance. So as an aside, MIT has, what do they have? 18 dot whatever, which means MIT has a hell of a lot of IP addresses, right? Any one of my friends can have as many IP addresses as they want for their personal computers. It's kind of a sore point. So we, on the other hand, are running out. But I think one comment I should make now is that there's not a one-to-one mapping between web page and IP address, but rather between web server and IP address. So you can have a billion different web pages, a billion different websites with different URLs on a particular server, but just have one IP address there. So again, we'll tease this apart a bit more tonight, but just as a look ahead, we, for instance, run our own server called cs75.net. It has, small white lie, one IP address, but we have 100 plus students registered for the course this semester, and all of you will ultimately procure your own domain names that you will host on cs75.net, but the rest of the world will not even know that. But 100 plus host name, or fully qualified domain names that you'll all buy for a few dollars from a registrar are all going to live on the same IP address. So we'll see some technologies even tonight by way of Apache, the web server, via which you can create this illusion of multiple websites living on ultimately just one IP address. And we'll also see some problems with that. For instance, none of you, afraid, will be able to use SSL this semester on our server, but that's fine because odds are you're not going to be taking credit card numbers or anything like that, because SSL, as we'll discuss in security context, requires a unique IP address, which is a little short-sighted or at least unfortunate. So more on that soon. So we'll tease all of that apart, but that's the short answer. Other questions? All right, so if we roll back to where we were in the story, I type CNN.com, I hit enter, my computer contacts a DNS server. Harvard says the IP of CNN.com is 1.2.3.4. I then make a second request from my laptop, unbeknownst to me, the human, but the computer does this, to 1.2.3.4. It goes from router to router to router, ... We saw all the routers scroll up on the screen. It then reaches CNN.com. CNN.com now takes a look inside this virtual envelope and sees, oh, the user wants our home page. So what it does is essentially the reverse process with the exclusion of DNS, because I already put in the return address my IP address. So CNN's web server opens its home page, usually called index.html or default.asp or whatever the default file name is, grabs the contents of that HTML file, spits it out across the internet, it reaches my browser, and then if it's a simple page, my browser renders, so to speak, all of that HTML. It parses it top to bottom, left to right. If it sees a bold tag, it makes text bold. If it sees an I tag, it makes text italic. But if it sees an image tag or a style tag or a script tag, what else might my browser do at this point? If it sees image source equals foo.jpg, what next happens? It goes back. So that whole process repeats, except for the DNS, because again, we talked about caching briefly. Thankfully, my computer's not so naive as to have to ask Harvard again and again and again for every request what the right IP is. And so my computer makes multiple requests, one for each of the files that is mentioned in the HTML source. So another issue we'll discuss over time in this course is issues of efficiency, whether you're using a mobile platform or even a typical website on a PC or laptop these days, because these days people are becoming more and more sensitive to the number of HTTP requests, we'll discuss that tonight too, that are going across the wire. Because long story short, anytime you make a request, as you can kind of imagine intuitively, there's some overhead. Like there's some metadata, all these IP addresses, they have to be sent. It's just more bits that have to go back and forth. When you don't care about these bits, you don't care about this envelope, you don't care about the return address, the to address, you care about getting the HTML back. So there's a lot of overhead with each of these requests. So you go to a typical web page today, and my God, there's dozens of images sometimes. There's flash files, there's movies. Every one of these requests adds up. So what we'll actually see as a useful tool in this course and beyond is this, again, tool called Firebug, freely available. And if I go to, for instance, cs75.net and hit enter, ironically, Harvard's DNS server seems to be slow today. Notice that the page came up again, but if I go to, let's see, net here, I have to actually wait. I have to click net, enabled. I'll explain in more detail how this thing actually works, but let me go ahead and make another request. This is Firebug. It fits into the Firefox browser. It gives me a window pane at the bottom of the screen and a whole bunch of functionality. And what I'm showing you now is kind of its network analysis feature, which shows you every one of the requests that went across the wire from point A to B, where A is me in this story and B is cs75.net. So you can see that even we aren't, even we have a bunch of content on this site. We don't have flash files, no movies, no audio, but we do have a bunch of JPEGs and GIFs, some JavaScript files, and so forth. So we have, like 16 files ultimately being requested every time you visit a web page. Now, this is not uncommon, and in fact, maybe just for comparison's sake, let me go and make this window a little taller. Let me instead go to, say, CNN.com, and I'm going to hide the actual news, because every time I bring up a news site, then all the eyes start reading, oh, that's what's happening outside of class right now. So we'll hide that and just look at the sheer number of requests that go across the wire. This ... usually means name resolution, DNS resolution's happening. Bam, so that went across. It's still, well, that's a bug. That's a little odd that it did that, actually. There we go. Oh, I see, because I haven't enabled it for this. All right, so Disney is buying, what's it called there? All right, so let me go ahead and hit reload here so that the browser actually cooperates. All right, 13 requests. 97 requests already for CNN.com, and it looks like it's still contacting Turner.com for some other stuff. So what is all this junk? I mean, some of it's images, some of it is sounds, flash files, a lot of it is advertisements, frankly, coming from other domains altogether. But every one of these requests takes some time. How much time? Well, not all that much, right? 1 millisecond here, 13 milliseconds here. But you start to add those up, and a page load for a typical website, it might take a second, 2 seconds, 3 seconds, 5 seconds. And that time begins to add up, and it begins to annoy potentially your users. So one of the things we'll talk about toward the end of the semester is the notion of scalability. It's one thing to live in this little sandbox, or this little sandbox of website development where you make a website, you put it on the internet, but problems arise, perhaps unforeseen problems, when it's not a user base of 10 people, or 100 people, or 1,000, but 100,000, or 10,000, or maybe just a few hundred, but they all have to use the same resource at the same time. Case in point, around submission time, around exam times on a typical college campus. Even in my courses, we have 300 students in another class. Thursday nights, you don't want to be trying to access the web server if there's not enough capacity, because we get all requests simultaneously. And this kind of stuff begins to hurt. And there are yet other considerations we'll look at as well. Yeah?
When people use the term page weight, are they talking about the number of files, individual requests, or the size of those files, or both?
Okay, page weight as in W-E-I-G-H-T?
Yeah.
So what does page weight mean? So that's a good question. To be honest, it's not an expression I use very much. I'm going to conjecture there's no formal meaning written down anywhere. So I suspect you can interpret it in the several ways you described. Ultimately, a reasonable measure is probably how many kilobytes or, God forbid, megabytes are actually involved in a page download. But, I mean, these things add up too. These add latency. And if you structure XHTML or HTML poorly, you can actually have the whole page load's experience, the whole page load delayed, because the browser is going to wait and wait and wait until it has all of the elements before rendering all of it. So there are some tricks that advertisers use a lot so that you at least let the page render, even if this thing, as in ironically this case, look at this, 148 now. It's the same page. We haven't done anything. Is churning and churning away, grabbing more content. Yeah?
So from the user's point of view, they would rather get a single request for like 100K than 20 requests for 5K each. That first one's going to look better than
It's a good question. Would you rather get one request filled with 100 kilobytes or 100 requests filled with 1 kilobyte? It depends on what you want to see. So for instance, if I visit CNN.com or any news site, I would like to think that they've designed their page in such a way, in terms of XHTML and structure, such that I'll at least get all of the text first, because I really don't care if I'm waiting and waiting for the stupid Flash video to download in the side. So I would say it depends. So there's no good answer there. It depends on what you want to present the user with. Other questions? Yeah?
The number of requests that continue to grow, and potentially the website itself making, or the page itself making a request back to the service that changes?
In that case, too, yes, because you see it flickering. Now that it said done, and I probably missed it saying done several times, it's probably using Ajax with a timer of sorts that's going off every few seconds or so that's re-requesting new content. But it did look like the first request at least had some 97 or so requests. But we too will do some Ajax stuff toward the semester's end. So we'll also talk again in this context of scalability. What a lot of people are doing these days is they're compressing their JavaScript. They're compressing their CSS. It's not hard. You'll run a command at the command line that makes what's human-readable code completely unreadable, or certainly annoyingly readable to a human, but it gets rid of all white space. It shortens the names of your very nicely named variables because the browser doesn't care what you call your variables. You're just wasting bytes across the wire. And to put this into perspective, I can note this. So we're all familiar with Google, for instance. So Google is kind of a funny case, and there was a fun article online. It's a nice little dichotomy there, Mickey and the Hulk. All right, so our DNS resolutions, again, are ironically taking a little while. So here's Google. So they're certainly renowned for the relative simplicity of their site, in contrast with a lot of other search engines, Yahoo with its categorization and all of that. And even Google's gotten a little cluttered over the years. Those links at top left and top right didn't used to be there. These things in the middle didn't all used to be there. But I'm feeling lucky has been there for a pretty long time. And the funny thing about this is there was an article few months ago, maybe a year or so ago now, about the financial cost of that button to Google. The feature of this button is to whisk the user away to the top hit without showing you a page full of results. So if I search for, let's say, Computer Science E75 Harvard Extension, which hopefully is specific enough that we're going to be the top hit, otherwise we've got some strange competition, I'm going to click I'm feeling lucky, and okay, we didn't reach our course's homepage, but something a little more official. We reached the course catalog on which we're apparently listed. So why did this just cost Google money? Right, I saw no ads, right? I was not one of these 1% of people that click on ads, and so they've just lost some number of dollars. And the fun thing about this article, and I'll try to dig up a link, was that this button costs Google, at the volume they do, statistically millions of dollars, but it's just something nice, right? It's part of their heritage, and Larry and Sergey or whomever liked the fact that this was in Google 0.9 all those years ago. But it's interesting to note, though, that besides things like that having really interesting effects when you start talking about scalability, right? When you get millions of hits a day, tens of millions of hits per day, every one of those fractions of pennies adds up financially. But also now imagine the bandwidth costs that Google has. And imagine a developer who very reasonably accidentally hits the space bar at the end of their file, right? Who notices space bar? Who notices space characters? Who opposes using indentation in code? But you hit the space bar once on a web page that gets downloaded, say, 1 billion times per day. That's 1 billion extra bytes, or a gigabyte of extra data that's been transferred for no compelling reason. And now think about the last web page that you made with all of your pretty printing and the indentation and your nicely long parameter names. All of those bytes start to add up. And so if only for the sake of the geekery of it, do start to take note for the next few weeks of what URLs look like at various websites. Notice how long the arguments often are. Now, Google uses Q for query. That's pretty darn efficient. But even Facebook is guilty of using fairly long parameter names sometimes, and many websites are guilty of using very long parameter names. But even these things have implications, right? You're going to be paying for bandwidth at some point, maybe not in your current job, but if you're the person who actually contracts with the ISP to get your customers to your site, that starts to add up. And it starts to add up really, interestingly enough, on these devices. So now we, developers, have to be all the more cognizant of even the cost of bytes when your bandwidth is just much lower. So it's not even necessarily a financial trade-off. So there's a lot of juicy stuff out there, and this course will hopefully give you little teasers or more rigorous introductions to a lot of these issues, but hopefully it will open your eyes to a lot of the ripple effects or side effects that happen when you're just not mindful of what you're really doing when you're at that keyboard implementing dynamic websites and ultimately popular websites. So any questions about DNS and data getting from point A to point B? No? All right. So let's go ahead and see what it's like to buy a domain name. So out of curiosity, how many of you have bought yourself your own domain name before? Okay, so actually that's quite good. Presumably not for this class. So those of you who've never bought a domain name, it's going to boil down to picking a registrar. The course is somewhat arbitrarily going to say go to godaddy.com, from which this particular ad comes. It's a weird name. It's a ridiculous-looking site. They sell domain names by way of girls in scantily clad outfits, but they're like one of the biggest registrars out there. They have really good prices, and the trade-off is that you get a lot of technical features too. So you'll see in Project 0, which will be distributed by morning via the course's website in PDF form, that one of the directives will be go buy a domain name. And we, again, just push you in this direction. We tell you to follow the various steps. As an aside, GoDaddy is notorious for upselling you at every possible screen that you visit. So you ultimately are just going to want to buy a domain name for like $9.99, give or take. But they'll try to sell you, much like a movie theater popcorn, like $20 website plan, $30 for SSL certification, and all of this stuff. So it's kind of an exercise unto itself. Find your way to the checkout point, at which point you then have to say, I don't want this for 2 years, this name. I want it for 1 year, and you change that little toggle. So it's a whole mess, but even I use them because technically you'll see they give you a lot of flexibility. You'll have a lot of fine-grained control over DNS. You'll be able to manage things en masse if you have a whole bunch of domain names, but you're welcome to choose another domain name, registrar altogether. So what does this mean? You go out there, you buy a domain name. What can you buy? Well, what domain names are available to people like us? Well, these at least, and even more these days, you can buy a .com, you can buy a .net, you can buy a .org. You cannot buy probably a what? .gov, .edu. I mean, there are some restrictions over some of those, but not over .nets, not over .orgs, contrary to what you might think. CS75.net just meant I had $9.99 and I went and bought it online. They're not limited to ISPs or anything like that these days. So there are some restrictions, but there's this burgeoning list of domain names that you can choose from. In fact, if I go to godaddy.com, again, DNS resolution is a little slow today for some reason. But when it does finally kick in, come on. There we go. And then the internet is fine. So when we do finally get to GoDaddy's home page, come on. There we go. All right, so she's always on these pages. And then you can see, I don't have a pointer today, but you can click on all these women's profiles of some sort. But this funny thing is, this is a totally legit website. This is not some sketchy website that I just found and now get some revenue from you all buying domain names. But you can start your domain search here, and notice just the size of this list these days. You got .info, net, org, me, mobi, us, biz, es, mx. There's a whole bunch in here. One that's particularly fun, I think, although I'm sure it will become passé before long. So .tv. So we actually have CS75.tv. We have camera in the room. We've filmed this course in prior semesters. Even you can go to CS75.tv and see the videos for previous incarnations of the course. And we'll similarly make this semester's videos available. But this isn't a domain name in the same spirit as .com and .net and .org. These two-character domain names, TLDs, top-level domains, actually belongs to a country. It's a country code. Just like .us, .jp belong to country, so does .tv belong to the little island nation of Tuvalu, which realized, wow, much of the English-speaking world likes TV and would really love to have the Sopranos.tv or the equivalent. Why not charge them not $9.99 but like $29.95 a year for CS75.tv and similar vanity names, because our country code just so happens to end in .tv. So literally, this has been a revenue stream. And you can Google this. You can look it up on Wikipedia. It's kind of a nice little story. And there's certainly other countries that have done this as well. But that's perhaps one of the most memorable ones. So if I go ahead and type in, let's say, David.tv, odds are this is not going to be available. They will try to upsell me various variants of this name. Once I click here, oh, look at that. The newest GoDaddy girl is online. The webisode. I don't even know what that would mean. So anyhow, maybe it's time to pick a new domain name, a new registrar. Okay, so David.tv is available. So are all of these other ones that they're trying to point out to me. And then they always have some stupid suggestions, incidentally, like mydavid.me, newdavid.me, davidnow.me. So just realize it's funny, for the course it really doesn't matter what domain name you pick so long as it's available. But one of the hardest things, frankly, about like starting a company for some people these days is about picking the company name in such a way that you also get the domain name, because it's really hard to find good available domain names because there's these people out there called squatters, and that's sort of a whole problem unto itself, just people who got there first and now want to charge you $400 for davidnow.com or the equivalent. So, yeah. So it depends. So GoDaddy, you can find domain names for less from smaller registrars. So several years ago, the organizations who run the internet essentially opened up registrations to multiple entities, some of which are fly-by-night operations that charge very, very little money. Some charge more. If we go to networksolutions.com itself, I mean, they'll charge you $30. And some people pay it because they know Network Solutions. They've been around for a while. You don't get anything more from them that you do from GoDaddy. You probably want to pick someone who's a little reputable. So paying $10 versus 50 cents probably gives you some assurance that they'll be around the next year as well. So it depends. It's become a market unto itself as to what you're... They are often paying, yes, so they've dumped thousands of dollars because, statistically, if they dump thousands of dollars on a whole bunch of domain names, 90% of which never get used, well, they can sell one for $10,000 to the company who really wanted that particular name. So, unfortunately, it's David.tv is really not worth that much money to me. So, yeah.
Are these domain names things that are going to need to be hanging around, or is this something I can use later in life for some company website and...
With regard to getting it for this course?
Yeah.
Yeah, absolutely. The domain name is yours to keep. The reason we ask students to get it is so that, one, you have a very real experience in the course so that you're not feeling like you're in this fake, non-real world environment. What you do in this course will be completely translatable to the real world and maintaining that site in the future. So yeah, once final grades are in, you're welcome to put up any website or none at all at that same domain, so long as you continue paying whomever the yearly or bi-yearly fees for it. Yeah. Other questions? Okay, yeah?
You get the weird domain names.
Mm-hmm.
It's like they never get run out of those. Do they go to this kind of websites and create, or?
It depends. So where do all these come from? There's many registrars out there. I suspect some of them allow you to automate the process of buying domain names, so you can just submit a list and check out with all of them at once. I think it really depends. And to be honest, I just have never squatted and bought lots of domain names, so I'm not sure what the way to do it is. So, but I'm sure some people make it sufficiently easy. Yeah.
So who's like on the top? Like who's getting, like the person that actually started it?
Who came up with the name of the idea of domain names? So. Right, so there's a couple of different organizations on the internet. One is the Internet Assigned Numbers Authority. They manage IP addresses. There's a similar authority that manages, ICANN, who manages domain names and TLDs specifically. So for the most part, those are nonprofit volunteer organizations, and these markets have been created whereby, I'm guessing, this too, you're pushing the boundaries of my knowledge of how it works up here. I suspect those agencies maybe charge some of the registrars for access to the database or the API via which domain names can be inputted, but there's no one. It's not like the U.S. government is raking it in because we invented the internet and created DNS and now are charging everyone else. For the most part, it's these middlemen that have created this market, and it's been opened up to them. But to be honest, I would have to do some research into that too. I just don't know the history as well. All right, so you buy this domain name. What does that mean technically? All right, so ultimately this is a course about getting one's hands dirty. What do you do once you've bought that domain name? Well, you have to tell the world where it's going to live. So there's two steps in bringing up a website, whether it's for this course or in the real world. You buy the domain name, and then you have to host it somewhere. So buying a domain name does not mean you have disk space or network bandwidth available to you. Those are two separate issues. So I go through all of the annoying steps of checking out. I give my credit card, I pay some tax, and for $10 or so, I now own a domain name. I then have to log into my registrar site, say in this case GoDaddy, and I have to tell GoDaddy essentially where is this domain name going to live. Because recall our discussion of DNS, someone's got to be informed from day one what the IP address is of davidnow.me. Or whatever my domain name is. Now, I don't know in advance, and you don't know in advance probably, what IP address your website's going to live on. You just know that the course called Computer Science E75 is going to do your hosting for you. Well, we, being our own little web hosting company for students, have our own DNS servers, much like Harvard does, much like Comcast does, much like most companies do. And those are called NS1, nameserver1.cs75.net, and ns2.cs75.net. And all of this is documented in the PDF you'll receive, so not to worry. So what you do need to do is tell GoDaddy, or the equivalent, that your domain will be managed by those two DNS servers. So in the future, if anyone tries to visit yourname.com, their computer will be informed, to find out the IP address for yourname.com, go ask ns1.cs75.net or ns2.cs75.net, because the owner of this domain told the world that those are the authoritative name servers for that particular domain. Yeah?
So when stuff we go in this class that's hosted here be available on the public internet?
Yes. Yep, everything you do in this course will be very real in that sense. And you'll be able to password protect it if you want, but it will be publicly accessible. Yep.
So we turn around and buy the DNS name, and then we tell GoDaddy or whoever that the DNS server is at ns1.cs75.net, and we finish up the course. What happens to all that storage that we just pointed to? So we own the name, but what happens?
You don't own the space or the server, because that's managed by the course. So so this course ends in December or so. So in November or so, we'll send around an email saying, hey folks, the course is obviously ending soon. You please make sure by whatever we decide, March, to migrate your files, anything you've done for the course that you care about and want to keep, to another web host altogether. And so one of the things we'll touch on tonight, too, are what are alternatives to cs75.net, which is clearly not going to be around forever. So fortunately, there's a whole industry of web hosting companies, not domain name registrars, but web hosting companies. So what you'll do at that point is just sign up for a few dollars a month or run your own server, and then go back 6 months hence, tell GoDaddy, you know what, I've moved my website. These are now the name servers who can tell you what the IP addresses are. So it's actually a fairly painless process. The only gotcha, as we'll discuss, is if you have a very popular website, changing your website's IP address or changing web hosts without your users or some of your users having some amount of downtime requires some careful thought and planning. But for most of the websites in this course, which will be, here's a website you can order some fake pizza from, probably not going to matter if it goes offline for a couple days. I saw a hand going up. Yes?
After we buy the domain name from the GoDaddy.com, and after we tell that it's going to be hosted in this DNS server, how is the IP address assigned? Is it some random algorithm?
That's a good question. So once you do all of these steps, buy the domain name, tell GoDaddy who your name servers are, who does the IP address assigning, that's when we take over. So we, the course, or we, the web hosting company, we decide that yourname.com has just signed up to be hosted by our physical server. You know what? We're going to give them IP address 2.4.5.6 because that's an IP address that we own or we control. So in our case, for cs75.net, we ourselves pay someone else for server space, so that we have our own server managed by someone else, which is convenient. But they gave us 4 IP addresses, one of which we'll share among all of the students in the course, one of which we keep for ourselves so that we, the course, can have SSL, so we can encrypt things like grades and private messages on the course's website and such, but we do all of that. And similarly with most web hosting companies, hide that detail for the most part from you. Okay, let's go ahead and take a 5-minute break. Welcome back. We're going to skip ahead for just a moment so I can make an introductions. In addition to lectures in the course, which focus largely on conceptual material and setting the stage for the week's material and for the several weeks project, we also have these things called sections, aka recitations, which are led by the teaching fellows. We have 3 teaching fellows for the course, one of whom standing to my right and will introduce himself in just a moment, and we have 2 others not here. One, in fact, lives as far away as some of you behind the camera there, Andrew and Dan being the course's head teaching fellow, who will help me with the management of the course. And here we have our 3rd teaching fellow, Sid.
Hi. Good evening. My name is Siddharth Chandrasekharan. I go by Sid, if that's easier. I'm a sophomore at Harvard College, and I'm studying computer science. I did the introductory computer science class with David last fall, and I TF'd E75 last spring. I had a really good time doing it, and I'm very excited to be here again. I look forward to meeting you all at section and office hours, so please feel free to get in touch.
Excellent. Thanks very much. So what sections are, for those unfamiliar, is once a week we will have a section locally on campus. For convenience, for those of you who would rather not try to commute to campus multiple times per week, we're going to run it right after lectures. So even though it makes for a long night, it makes for less commute. But it will be filmed, so if you're completely exhausted or wiped out after I talk for 2 hours, you can head home and watch it online. But we will also have an online section as well that will be recorded digitally. So Andrew actually lives down south. North Carolina. He will lead via some web conferencing software, an online section, which is meant to be a supplement to this section as well. And via that session will he be able to present some slides, screen sharing, chat room. There'll be multiple means of accessing the course, whether you're physically sitting here or live nearby or even tuning in from afar. So more on the latter shortly, but this first section will not be tonight, so we won't catch you completely off guard, but next Monday after class will be the first section. And what sections are about are recapping some material, maybe fixing any mistakes that I make or inclarities that come across, but ultimately focusing also on the projects, how you begin the week's project, what you should do, what you should think about, so that you have some more specific practical advice when it comes to the course's projects. That's what sections will largely be about. And we'll also offer office hours, sort of one-on-one help on demand usually, so that if you would like to chat more intimately with one of us or focus on your problem that you're having with code that isn't very well shared, say over email, and want to just stick around after class, we can set that up as well via email. Yeah?
Labor Day weekend, no class, right?
Oh, yes, so thank you. Good correction. So next Monday, we actually have a little hiccup in the schedule because it is, in fact, Labor Day, so 2 weeks. So it'll be after the next lecture, which is 2 weeks hence. So, and all of these dates are, for lectures and such, are on the course's syllabus. So let's do this. Since we dove into this discussion of sections, let me go ahead and give you a quick sense of the course before we turn to things more technical. So the prereqs for the course, and this is a common question, some of which came up during the middle of our break there, is what's expected? Is your background appropriate? And it's kind of hard to answer that because it really depends on what your experience has been and what your background has been and what your sort of level of time and energy is for the course. But officially, the course requires that you just have some programming background, and something fairly modern is ideal, something from C on up, PHP, Java, JavaScript, Perl, Python, really any modern imperative programming language. It will make the transition to this course much easier, and then some experience with HTML. Now, with that said, as I said to some folks during break, we've absolutely had students take this course who have had just one semester of programming background from, say, the equivalent of Computer Science E50A here, the Intro Java class. I would caution that those students have definitely worked harder or spent more time, maybe struggled more than students who are full-time software developers, but just in a very different programming context. So we have really a range of students. With that said, realize we will absolutely bear in mind over the course of the semester where you started and where you finished up in terms of comfort and abilities and quality of work and such. So just because we do have full-time developers and aspiring computer science students in the course, one does not really affect the other when it comes to grades. So do realize that that should not be a barrier to sticking around. But then feel free to chat with me or chat with us over email if you have questions about your particular background. Expectations. Attend or watch each of the lectures, since it's in those that will set the stage for, again, projects and the course's ultimate content, and then implement 5 projects, 4 of which will be assigned by us, the 5th of which is a final project. More on that in just a moment. What are we going to be covering in this course? So this is, again, on the syllabus. All dates are there. But tonight is about, one, introducing, as we've seen, things like HTTP. We'll come back to that, and DNS, and registration, and really giving you a sense of what it means not just to build a dynamic website, but how you even get it online, and what you do with it once you've designed it, and how you get it off of there. So sort of soup to nuts. Next week, though, we'll dive into PHP. A server-side programming language or scripting language that's very popular these days for web development because it was pretty much designed with website development in mind. In contrast to, say, something like Perl, which at least initially you had more hoops to jump through just to do some basic web interactions. And even C and C++ could be used for web programming, but it's a nightmare. So what's nice about PHP in particular is, frankly, if you're coming at the course with a programming background from a completely different language, which most people are, it's really easy to pick up, partly because the documentation, frankly, is amazing. Even better, I would say, than JavaDoc, because it's not as overwhelming with the sheer hundreds of classes that Java ships with, but the documentation is really good. The function suite is very rich. Pretty much if there's a function you wish existed, it probably does, which is advantageous as well. And it's just very easy to get things up and running. With that said, it's also easy to get bad code up and running. It's not the neatest language. You will find, at least early in the course, that we'll actually allow and encourage intermingling of presentation and data. So intermingling your code with your HTML, maybe with your CSS, mostly because it's very easy to get things going that way. And then you can later, especially at final project time, think about how can you even better design the software, especially as your projects get much larger and maybe involve other humans. So we'll spend a couple of weeks focusing on PHP. I'm going to give you an introduction not just to the syntax, which is not very interesting and is frankly very similar to most modern languages, but the features that it provides, what it means to manage sessions and shopping carts, what is get, what is post, how do you actually move data from client to server and back. We'll also look for a couple lectures at XML, which in itself is open bracket, something, close bracket. There's not much there really at first glance, but it's a really useful meta language or set of meta languages with which you can implement the equivalent of configuration files or databases. In fact, the first project for this course, the first real project, Project 1, we won't use MySQL. We won't use a real database because, as you'll see, the application just doesn't really demand it. It's kind of overkill. It's a lot more work to get a database set up when really a flat ASCII file suffices. And its XML is hierarchical in nature. It's very similar. If you're unfamiliar completely, think of XML as HTML, but you get to invent your own tags. And so you can create structure and hierarchy and store your own kind of data, not just aesthetics. So we'll focus on that and also some of the related languages like XPath, the XML path language with which you can query data from an XML file just like you can query data in SQL from a SQL database. Really useful, and even we use it for the courses website. All of the pages that you see that are dynamic change every week, like the lectures page will get updated, the sections page will get updated. We don't ever really touch HTML in the course ourselves. We just edit a couple lines in an XML file, and voila, we get more handouts linked automatically on the course's website. So it's useful just for simple little things like that. SQL we'll introduce. This is it comes in different variants depending on the database server you're using, but this is a language via which you can select information from a database, insert info to a database, delete from it, update it. So this will be a language that we will use with the very specific MySQL database implementation. There are alternatives. Oracle you've probably heard of. Microsoft Access you've probably heard of. There's SQLite. And there's a whole bunch of others out there. MySQL is nice because, one, it's very popular. There's a large community behind it. It's very free. At least the free version is free. You can pay for support if you want. And it's pretty darn high performing these days. Even Facebook, for instance, is renowned for using MySQL for much of their backend and even contributing, I think, some of their own optimizations to it, at least underneath the hood. So it's definitely capable of scale, and that too will be one of the foci for the course. Yeah, so PostgreSQL is also very popular as well. No, there are definitely some differences, and truth be told, I sort of grew up with, so to speak, using MySQL. I considered Postgres at one point, and just at a friend's recommendation, I decided to stick with MySQL, but based only on a casual conversation. But it, too, is very popular, though I don't think it quite has the same user base that MySQL does these days. So MySQL is very well maintained, again, very high performing, so I at least have not had much cause to go shopping around for another free option. All right, so we'll transition from SQL, where we'll actually have a real database server in play that you'll then use for the latter half of the course, to things more client-side, and that's our major transition. We'll focus on JavaScript, and not just doing annoying little things like triggering pop-ups from yesteryear, but actually validating user input and creating more effective user interfaces because you're pushing some of the code down to the browser where it's closer, where it's faster, and more immediately interacting with the user. But then we'll do some stuff that's much sexier with it, namely AJAX, formerly stood for asynchronous JavaScript and XML, all capitalized. These days, some people like us lowercase it simply because it doesn't have to be XML anymore. So we'll talk about XML, we'll use XML, but you don't have to use XML for AJAX because it's actually a fairly weighty transport mechanism. There's a lot of fluff, open characters, quotation marks. There's a lot of bytes that you have to ship with an XML file that just take up space. They take up bandwidth and they slow things down. So we'll talk about just sending raw XHTML or HTML down the wire, which is very easily generated, or a fancier approach called JSON, JavaScript Object Notation, which is even more compact. And ultimately, that's all about getting more data from server to client on demand. So when you click and drag on Google Maps and you see for a split second sort of a nothingness sometimes, little gray or beige squares, and then all of a sudden these additional tiles come in, that's because Google was one of the earliest users of this AJAX approach, whereby when you click and drag, their JavaScript's doing some mathematics and realizing, oh, I don't yet have those tiles for up there and up there. Let me recontact google.com, get 2 more JPEGs, and then plop them into the div or whatever it is that represents that map there. So we'll be able to do stuff like this. We'll talk at term's end then very specifically about security stuff. What do you need to be mindful of? What are some very common attacks? What are very likely attacks? And then also talk at term's end about scalability. So how do you design with not just a few dozen or a few hundred users in mind, but a few thousand, all of which might need something at some particular point in time. And it's ideal if your website not go down cyclically just because your traffic is itself cyclical. So we'll talk about good design techniques for that. So what are the projects? Well, Project 0 is very low-key, and you have a bunch of time for that, but that's only because we need time to really present you with enough background with which to really hit the ground running with Project 1. So Project 0 will have you answer some setup questions, fill out a survey, buy a domain name, set up your DNS, but you will be very methodically walk through these steps in the course's PDF, which again will be posted by morning. Project 1 is the first real project, so to speak. Pizza ML, markup language, whereby we will present you with a PDF of a local pizzeria's menu. They sell subs, they sell pizza and salad, but they don't yet have an online ordering system. And the owner of this shop would really like your hand, him being a buddy of yours, and so you're that person who always gets tapped on the shoulder when something technical is needed. So you're going to need to implement a website ordering system for that pizza shop. But the catch is it's got to be simple. This is not a technical guy. He's not going to know how to manage a MySQL database, and you kind of want to wash your hands of this project as soon as it's done so that he can help himself changing prices and adding items, removing items. So the approach you'll be asked to take is to model this menu as a database, but in XML format. Because the guy at least is going to be comfortable enough with like Microsoft Notepad or Mac's text edit program. He can at least do those kinds of edits, very low overhead, and you then don't have to be involved. So you'll need to be able to empower users to add items to a shopping cart, specify little notations or customizations potentially, check out. You'll need to send them a receipt via email, and ultimately simulate the process of ordering. So that'll be Project 1. Project 2 is about implementing CS75 Finance. So you will actually write code that interfaces in real time via HTTP with Yahoo Finance. You'll get nearly real-time stock quote prices for any real-world and publicly traded companies, and you're going to have to empower users to create an account, get $10,000 of virtual cash, and then they need to be able to trade stocks. You need to be able to give them quotes on stocks when they ask for them. You need to be able to let them buy shares of stocks, sell shares of stocks, tell them the current value of their portfolio, and we'll try to turn it into a bit of a competition whereby we'll rank, if you opt in, your own personal profile. We'll give all of you 10,000 virtual dollars to play with the course's implementation of the project so that you can see. And this was not a good fall to do this in when the course, or a good spring to do this project in, since everyone's portfolio is really kind of tanked. Except for, ironically, the completely bogus penny stock that I bought in our version based literally on a piece of spam I got. I actually did very well. But none of us ended up cashing out very well. But you'll ultimately implement a website much like E-Trade or the like. And finally, Project 3 will ride this wave of buzzwords, mashups. And you'll implement your own mashup using Google Maps and Google News, whereby we will hook into Google News' RSS feeds, which, as you'll see, is itself XML-based. You'll pull that data in so that when a user visits a particular portion of the United States using Google Maps, they'll see little markers for all of the largest cities within view. Click a marker, and your code will go talk to Google News, say, give me the latest articles for Cambridge, Mass., for Somerville, Mass., for Beverly Hills, and then show in a little Google balloon window links to each of those current events and those actual news articles. And that will involve a lot of client-side code. And then finally, there's the final project. In the last few weeks of the course, this is when we turn the reins over to you, ask you to propose a project that's manageable within the remaining several weeks of the course, and implement something yourself that applies the course's lessons that you would find fun, that you would find useful, and that ultimately wraps up the course. And at course's end, what we'll do with all 100-plus students in the course, even those who are distant, if you can travel to campus, we'll have the third annual Computer Science Fair. This will be joint with Computer Science E7, which is actually Dan Armendariz', the head teaching fellow for this course. His own course, which is being taught right now, which is why he's not here, he teaches a digital photography course. So just as his students will be creating very beautiful works of art using digital photography, you'll be creating very beautiful work or very functional works of art using PHP and JavaScript and SQL, and we'll all get together in the computer science building, bring in laptops, and exhibit final projects to the group, mingle, say hello, eat some cake, and ultimately wrap up the course in a very social way. So that'll be happening later in December. Any questions about the course's projects? No? Okay, so just in terms of resources, realize that the course has no required books, but we do recommend one of two sets, so to speak. So you can find these at the Coop, as well as in Grossman Library, and much more expensively, certainly than the former, on Amazon.com and the like. If you are among those less comfortable, shall we say, who are coming into the course feeling a little unsure you should be coming back in 2 weeks' time, well, these books are really very user-friendly. So they're very technical, and they'll certainly help you learn how to program in these various languages and technologies, but they kind of do it in a very, very nice user-friendly way and make few assumptions as to your own background. But if you're coming at the course where you kind of don't need your hand held when it comes to what XHTML and CSS are, this is also a nice set of books. And all of the ISBNs and such are in the course's syllabus for these. These are sort of more reference books that those of you who like having a little book by your side realize that these are books that in our experience we have liked. I should caution that one of the books on the previous slide is now out of print, but it's still available on Amazon.com, and frankly just getting used versions of most of these is probably sufficient. With that said, Google is a wonderful place to start, though, for resources. There's no reason to buy books for this course, and even we on the course's website's resource page will point you toward any number of resources that we recommend for various languages and techniques and such. So you'll find that most everything is available to you there. CS75.net is the domain name that we bought for the course. You will find links on this site to lecture videos, MP3 files thereof, to PDFs of lecture slides, PDFs of projects. There will ultimately be a bulletin board link. So once you have submitted Project 0, which again will be posted tomorrow and be due a few weeks later, once you've submitted that, we will give you an account on cs75.net that will let you log into the website, which you don't need for much. Almost everything is publicly accessible, but when it comes time to check grades, you'll need to authenticate. When it comes time to log into the bulletin board, you'll need to log in. And the bulletin board will be meant for Q&A, back and forth with the staff and also with fellow students. We'll ask, and we specify in the syllabus that you not cross the line of sharing, say, actual code with other students, but rather keep things a little more abstract, or at least just snippets of code if you're having a very specific problem. But it's a great place for chatter among students, chatter between staff and students, and to get questions answered that are not, say, here's my 30 lines of code, I can't find my bug. That's where help@cs75.net, the email address, should be used instead. So you will see a number of resources there. In fact, also on the course's website will you find ultimately a link called Virtual Terminal Room. So even for those of you local or those of you playing along afar, we have used this web conferencing software that I alluded to before that Andrew will, yes, use for sections, but it's also sort of think of it like tech support for Dell, but for academia. You can log into this Java-based software from any browser, any operating system, and it gives you a glorified chat room. But what's nice about this is that we, the staff, log in as moderators, and what this means is we can ask for your permission to share control of your mouse and your screen, so we can actually see in vivo what problem you're having, say, on your terminal window or on your actual computer screen. Where are you going to be developing your code? So now this is when I can roll back to before Sid came in. So how are you going to be accessing CS75.net? So CS75.net is effectively going to be your web host. And to be clear, after you exit this course, we probably won't continue to be your web host unless you retake this course in perpetuity. And so there's going to be some third parties you'll probably want to turn to. Google web hosts tonight, and you'll see a ridiculous number of options. Anyone and everyone with a server these days can be a web host. It's that easy, but you get what you pay for. So for a while, I was paying $2 a year for a web host. Very often went down, surprisingly. But I did it for just a silly vanity domain name and to see what it was like. It probably was some guy in a basement with like an old 486 computer that he didn't have any other use for, but he had an IP address. He had some web serving software and email software, so he was a web host. So realize there are some big fish out there, and this too is a great topic when it comes up for the course's bulletin board. This is a screenshot of a popular one called DreamHost, but don't write that down because we're now very anti-DreamHost, having had a very bad experience paying just $20 a year for a service in a previous semester. They just got a little overwhelmed. And it's not one guy in his basement. It seems to be 2 or 3 guys in their basements. They have a rich set of features, and so I kept the screenshot because what you see here, though small on the screen here, is representative of the feature set that you can get these days. You can pay just a few dollars a month, even from reputable folks, and get unlimited email addresses, database access, even SSH terminal access, unlimited domain names even hosted, but realize too you'll often get what you pay for. So there's probably a sweet spot, paying something in the like $10 to $50 per month, and you probably are getting quality. Less than that, you're probably rolling some dice. More than that, and you're probably getting taken advantage of. So we'll talk about some of these commercialistic aspects, certainly one-on-one or via the bulletin board as they arise, and definitely toward term's end. So we ourselves use this technology, so to speak, called a virtual private server. So it's just as popular these days for people with computers better than 486s, so more modern hardware, to realize, you know what, I have like 2 3 gigahertz processors here. That really is overkill for word processing and browsing the web. Let me actually carve out some of these resources and share them with other people, but still give them the illusion that they have their own dedicated server. So this isn't as often just guys in their basement. These are real companies that buy commodity x86 hardware from Dell, IBM, HP, whomever, but they buy it with a lot of CPUs or a lot of cores, so to speak, a lot of RAM, a bunch of disk space, but way more than a typical person or even a typical website needs. So they run special software that creates virtual machines on this hardware, where you get the illusion of multiple Linux servers or multiple Windows servers all coexisting on the same hardware, but in a way that's very much hidden from the user. So CS75.net is actually hosted by a company called Servant, who we've just been fans of because the thing has worked wonderfully for the past few years, and they've given us an academic discount since we've been using this for course purposes. But they have some hardware that they have lots of servers that they carve out using virtual machines. Virtuoso is the software they use, or Parallels these days, which you can use on your own servers if you like this kind of thing. And what they give us is some dedicated resources. So we get, and this is a little small here too, but we do not pay the price that's depicted there, but we get 2 gigabytes of RAM available to us and all of the students here, 100 gigabytes of storage, which for most of the websites in this course is way more than we even need, 3.5 terabytes of monthly transfer. So that too is actually a topic we'll raise during scalability. Long story short, we've been podcasting this course and others of mine, and we've actually seen in a typical month for one course 4 terabytes of downloads of like QuickTime files. That's a lot, and that costs a lot of money with most web hosts. So there's a lot of interesting axes to be mindful of if you are expecting, depending on the type of website you're running. If it's just dynamic and spitting out a few kilobytes of HTML and CSS, probably not going to exceed your bandwidth. Start providing people with videos and streaming content and this stuff, then you got to be much more careful with details like this. And it was a mess at first. We did not expect that load in 2006 when we first started doing this. So I think I signed us up for like 3 DreamHost accounts and wrote a script that essentially said if we've exceeded our bandwidth on this account, bounce the user to this server, and then bounce the user. It was not a very good solution. So now we host everything locally. Where bandwidth is free since Harvard takes care of it somehow. So that's what CS75.net is, but what does that mean for you? How do you actually interact with CS75.net? Well, it's just a Linux server. It's running an OS called CentOS, aka Red Hat Linux. you will have access via SSH to a shell, so to speak, which if you've not been familiarized with that before, you can be at the first section led by Sid on campus. But that you often don't need to resort to a command line. If you're more the type who prefers web-based management, what you'll find is that you can go to panel.cs75.net. You'll be prompted to log in, which you'll have a username and password for after you submit Project 0, and you will get a very nice GUI interface with which to manage your domain name. So what you'll see here, for instance, is this. If I log in as Malin here, using my account, I'm going to go ahead and click Domain Administration. We will do this for you. So let me do something a little fake here. And what was it? davidnow.me. So suppose I did buy that. Suppose I did tell GoDaddy my name servers are ns1.cs75.net and the other. What I will have now, and we'll do that part for you, you will log in and you'll see something like this. This is what's generally called a panel or a web panel, and it's just a more user-friendly way of managing what's usually a Linux server for web hosting purposes. So we present this as actually representative of what you would get if you paid a third party for a server. It's non-trivial to pay for just a VPS and be handed the keys or the root password to a Linux server and then say, okay, go install your web server, install your database. There's a lot to that, even for technophiles these days. But what's nice about most web hosting companies, including our own server, is that you make those basic processes like adding DNS records and creating new websites and creating new databases just much easier. Click a few links, type some keys, hit enter, done. So that's what this is. It's about simplifying the process of managing a server. So the panel we use is called Direct Admin. It is not freely available for commercial use, but frankly, it is, in my experience, the best out there. The alternatives, and unfortunately the more popular alternatives for note-taking purposes are called cPanel, C-P-A-N-E-L. That's probably the most popular, followed by Plesk, P-L-E-S-K. I hate them both. They are very complicated, honestly. They do the same thing, but much less consideration, I think, was given toward the design and the user interface. And as technical a person as I consider myself to be, I don't like fighting with just poorly designed software. So a random plug using this panel was chosen, or this panel was chosen for the course because of its sheer simplicity. So what do I mean by that? Well, early on, you might actually want to create an email account within your domain. So you've just bought davidnow.me. I really want an email address within that domain. Well, cs75.net does support email. You can click email. Okay, I can click email account, and I can fill in this little form, and bam, now I have an email account that I can access via our web mail interface, or as you'll see in a welcome email we'll send you after submitting Project 0, SMTP and IMAP and POP and all of that. So it's just very easy. So we hope that you'll find that this panel does not get in the way of the actual interesting stuff in the course. Creating email addresses, really not a fun, interesting intellectual exercise. Writing code, more interesting. So this kind of lets you get the job done without getting in your way. So this is something you'll use occasionally, but typically just at the start of a project to create something that then works in perpetuity thereafter, like a database. So more on that in the projects to come. How can you access your account? Well, if you're familiar, you can SSH to cs75.net, and once you have an account, username and password, you'll get a blinking prompt, and you can do some stuff there. What does that mean? Well, you can write your code at the command line using Emacs or Nano or Vim or any of the tools that are installed. You can upload files to your account. And these are various popular Linux commands. You can SFTP stuff to your account, and this too will cover in section if need be, secure file transfer protocol. If you want some silly image on your website, that's fine. Just click and drag it using an SFTP client. Freely available programs exist. We'll talk about those in sections. Long story short, it's a server, cs75.net. All of your domains will ultimately live on this server. When you develop a project, you can write it anywhere, including on your own laptop, workstation, wherever, but you eventually have to upload your code and make sure that it runs on cs75.net for a couple of reasons. One, then we have access to it. Two, we know that it works within our particular framework, which is very standard, but this way it certainly simplifies the process of looking at 100-plus people's code all at once. And two, it's very representative of a real-world process. Develop anywhere you want. Make sure you're writing portable code that you can click and drag and upload elsewhere, and it will also work in that environment as well. So with this said, if you're coming at the course with less of a background in or interest in a Linux environment, that's fine. What you need to do on cs75.net is very minimalist. Really just making sure your files get up there and you make sure it's working is really all you need to do, and you'll need to run a command to submit your file so we know when to look at your code. But if you just are the type of person who really likes your own local system, you don't really want to SSH all the time because it's not as high performing. You want to do everything locally. Everything we do in this course uses software that's freely available. So Apache is going to be the web server. PHP itself is free. The M in LAMP is MySQL. That too is free. And all of this can be done on your own computer. It's a little annoying, though, to have to download the L, the A, the M, the P, and all of that. So fortunately, there exist some packages that let you download all of these things at once. One of them is called XAMPP. One of them is called WAMP. We'll point you at this on the course's website. But what we will also do this semester for the first time is allow you, probably for Project 1 onward, to download your own virtual machine. So just as people are using virtual machines on servers to give lots of people the illusion of multiple servers, so are people like us using virtual machines to create the illusion on your own Mac or PC that you're running Linux. So for years, I toyed with like dual booting. You might be familiar with Boot Camp on a Mac or just dual booting on a PC. It's really annoying, frankly. Like you have to reboot your whole computer just to change your operating system. I used to do this I used to always have 2S's installed. I always used to use this one or this one. Like it never rebooted. What virtual machines are letting people do is run 2 operating systems at once, whereby you run Mac OS or you run Windows, but in the window on your own OS, you run Linux or Windows. Can't do Mac for licensing and technical reasons often, but what we'll do is provide you with freely available software. It's made by Sun Microsystems called VirtualBox. We'll put together a little Linux image that you can then download to your own computer, and then if you want, you will have your own sort of sandbox environment configured almost identically to CS75.net. But it's local. You can take it with you when the course ends. Your domain name is not going to point to your own laptop. At the end of the day, it still needs to be moved to cs75.net, but it will give you this little development environment that's identical to the course's setup that works offline. You don't need internet access, and so we think it'll be both useful and also a fun technology to play with. So most recently, I'll confess up that I use this virtual machine technology because I have a little MacBook Air here, but I was going on a really long flight, and my sister had just given me for like my birthday the King's Quest game from like 1988 or something like that. So I love this game. It was like the first game I played as a kid, and I really wanted to play it again, but it's for Windows only. Frankly, it was for DOS only back in the day, and it actually comes with a DOS emulator these days, but I really wanted to play it on this flight. So I downloaded VirtualBox, which is, again, this free VM software. I installed Windows inside of it, and like a real geek sitting there on an airplane, not only was I using my laptop, I was using my Mac to run Windows, to run DOS, and play King's Quest, which is like one of those 4-bit games where the secret thing you need to find is just a single blemished pixel on the screen, and oh, I got the carrot. It's a great game, though, nonetheless. So we'll use it for more educational purposes here. Yeah?
Have you had any luck, trouble with VirtualBox running more high-level software that's anal retentive?
Wait, software that's anal retentive?
Yeah.
What do you mean?
I have really picky software that's for my medical office.
Oh, I see. So that's a good question. In my experience, graphically intensive programs, like I probably wouldn't. Photoshop should work, but I wouldn't try playing like Microsoft Flight Simulator or Quake or something that's really taxes like your graphical processor. So I've not used it with many applications. It's easy enough to try. If it doesn't work, okay, it doesn't work. But for the most part, these software, and VirtualBox is just one. There's VMware Workstation, VMware Fusion for Macs, there's many other options still. At the end of the day, they're supposed to provide software with the illusion, or the operating system with the illusion that they are running on a typical PC. So in theory, it should work, especially if you go with one of the paid-for options whose QA people have just often done more testing. So good question for the bulletin board, too, just because my experience is limited. Okay, so just to dot a couple of I's, let me actually scroll back to one thing I glossed over, which was this, which is actually a little nice diagram someone put, I think, on the actual Wikipedia at one point. I really took for granted earlier the fact that Harvard knows where CNN.com is. Why would Harvard know where CNN.com is, or why would Harvard know where davidnow.me is, right, if we pick a really small corner case? Well, it probably doesn't, the day the sysadmins install that DNS server. How would it know what davidme.com is? So fortunately, there's a whole hierarchy in the DNS system. And we actually talked about the closest guy and the farthest away guy, GoDaddy and registering the domain name and telling it who the name servers are. But there's also this hierarchy in between. So Harvard has an ISP or two, and that ISP probably has domain name servers. If you go home tonight, you have a DNS server, maybe in your home router even, and that guy talks to Comcast or Verizon's DNS server, and those guys in turn might talk to some bigger fish. But at the end of the day, there are also some very large root servers, so to speak, that are ultimately responsible for knowing where all of the .com addresses are, and another, where are all of the .net addresses, and so forth. Sort of the buck has to stop with someone. Someone's got to know. So when you are submitting to GoDaddy, ns1.cs75.net and ns2, what you're essentially informing is those root servers of who the authoritative name servers are for this little domain here. So what this picture depicts is the recursive process that very often happens with DNS. So if I'm the little guy over, not even depicted on the screen, and I contact harvard.edu, and harvard.edu, or rather, let's say my home Comcast connection. Well, okay, we'll pick Harvard. Doesn't matter in the story. So Harvard's DNS server just has never heard of davidnow.com. Or in this case, I've never heard of www.wikipedia.org. Well, fortunately, Harvard's server has been programmed, in worst cases, to at least contact the root servers. And the root servers will tell Harvard whom to ask next for the answer to the question, what's the IP of wikipedia.org? In this picture here, that root name server says, you know what, try 204.74.112.1. Well, whatever. But that apparently is the IP address of a name server called the org name server, the guy that knows about all of the orgs. So in short, there's this hierarchy out there such that if this guy doesn't know, he asks someone who's a little bigger, a little more important from him, and maybe from there to the next person, and then finally, ultimately, to the root servers if need be. But fortunately, the smaller fish, my Harvard's DNS server here, my DNS server in my home router or running on my own network, because of caching, they're supposed to remember these answers for at least some amount of time. And that's great, because the internet would probably start to break down if every time I hit enter on my keyboard, we kept asking these same relatively few root servers. So caching is good, except in cases that we'll discuss throughout the term, like what if you have two web servers and you're load balancing across them so that some people go here, some people go here? What if this guy goes down? And what if the guys who've been going here have cached the IP address of this server, not this server? Well, you get dead ends. What if you want to change your IP address because you're moving offices, you're moving ISPs? Well, then you're going to have two dead ends. So DNS is wonderfully flexible, but it really can bite you when you want to do something like take down a server, or it goes down unintentionally, or you want to move around. So we'll talk about those technical things too. So that's a good question. Ironically, I would turn to Wikipedia for some of these answers. In the case of, in most of the fish in the story I told would be Harvard pays for theirs and Comcast and Verizon for theirs. The top level, to be honest, financially, same answer as before. I'm not quite sure with some of the financing of it, to be honest. So the main backbone providers to the...
You can't... If you're going to provide a pipe, then you have to provide access to it. I don't remember all the details. But
yeah, so I too. I'll try to do my homework though.
If you buy a big pipe from AT&T, for example, then you have to, part of the price of having a T1 is that you probably buy the service. This is what a hand wave is.
Oh, sure. No, and so fortunately, I have 2 weeks where I can come back, sound even more intelligent, and answer that even more effectively next semester. So, yeah.
Like on my router, it has this thing where you go to dlink.com with like dynamic DNS.
Mm-hmm.
How do you?
Sure. So a little tangential, but very easily answered. There's this thing called DDNS, or dynamic DNS, which essentially means this. You go to dyndns.org. They're a very popular one that even I use, DYNDNS, and there's many other people like this. You get a host name like david.dyndns.org, which I don't really care about. I'm not going to advertise that as my URL, but I, for instance, like to SSH to my home server sometimes, or to use remote desktop to connect to a Windows machine and things like this. But my IP address from Comcast or whomever can change, even though it doesn't often. So I could just remember my IP address, but occasionally, damn, it's going to change when I'm out, and then dead end, because it's leading to some other customer's computer. So what dynamic DNS services do is essentially you install a little program on a home computer. It periodically polls the company you're using, and it says, hey, my IP address is 1.2.3.4. Hey, now it's 1.2.3.5. And when I then try to connect to david.dynDNS.org, the DNS server involved is theirs. I am then informed of my latest IP address so that I can always find my home. And I actually use this myself for my Slingbox, this device that lets you stream TV and TiVo on the internet. I really would be annoyed if I couldn't watch my TV show on the road just because Comcast changed my IP. So there's some fun solutions to this, too.
Run a whole server that way?
You could run a whole server that way, but there are more robust solutions since there can be caching issues there, and also it takes time sometimes for these updates to propagate. So we'll discuss more robust solutions over time, or certainly can. All right, so where are we going? So HTTP, Hypertext Transfer Protocol, is the language, the protocol, that web browsers and web servers speak. And this is something you'll get much more familiar with in the course, especially as you start sniffing your own traffic between web browser and web server. So what do I mean by this? Well, thus far tonight we talked about this virtual envelope and a request going from here to CNN.com or 1.2.3.4. But what was inside of that envelope? Well, casually, it's just a request. Give me your home page. But what does that really mean? Well, really, it's something a little more technical, like get, in all caps. What do I want to get? I want to get /index.html. And hey, just in case I have different versions of software running, what version? Well, I'm going to request this via HTTP/1.0. So what's inside that envelope? Literally a string that pretty much boils down to just that. Now, how can I convince you of this? Well, again, one of the wonderful uses of Firefox, at least in this context, is another free plugin. All of these are linked on the course's software page on the website called Live HTTP Headers. I should say for this course, too, we really don't care what browser you use, but each of the projects will require that your website, your project, render the same on at least 2 major browsers, and we enumerate version numbers. So it's got to work on, say, IE 7 and higher, or Chrome 0.9 or 1.0 and higher, Firefox 3 and higher, Safari 4 and higher, and so forth. And the exercise there is, one, not to drive you completely insane, because getting a typical interesting website to work on all major browsers is actually a nightmare sometimes, because there are little differences in Microsoft's and Mozilla's and all these people's interpretations of specs, and sometimes just outright mistakes. So that's kind of a nightmare. But it's a good exercise to at least experience this in part, and hence this requirement you'll see of requiring that your sites work the same and look the same on 2 browsers. Now, from a developer's perspective, I would hands down use Firefox for much of the semester because it has so many available plugins, a few of which are really killer, especially this Firebug plugin. Safari and WebKit, or Chrome in term, are getting better as well. But you'll often see me using Firefox, not because we care, but because it's so useful. So, and all of this, again, is free. So this little window, as you might see here, is going to let me sniff some of my own HTTP traffic. So not TCP IP traffic. We're higher level tonight. So what if I go ahead, I'm going to make this window off to the side, but I'm going to go to CNN, www.cnn.com. And I don't care about the news. I'm just going to watch this window here. So we got a little DNS name resolution slowness going on. That's just a Harvard thing. But what just happened was I see now the headers for the website, the headers for the requests that just went across, and all that crap that's inside of CNN.com. I mean, what you're seeing is the request being made for every GIF, every JPEG, every Flash file, every CSS file, even the original index.html file. Now, this window will probably keep scrolling as AJAX is being used to get more data, so I'm actually going to close this window so that the scrolling stops, but I'm going to focus for tonight just on the first. What was the first request that ran across the wire? Well, it was this one here at top left. Inside that envelope was literally get / I didn't type out the default file name, so it was just get / HTTP / 1.1 in this case, slightly newer. Yeah?
Is that also happening over HTTP, those initial requests?
Good question. Short answer, no. What you see is HTTP. So everything we discussed prior is actually lower level and is done by a protocol called TCP and IP. So that's lower level, and you could sniff that with something called Wireshark or something similar in spirit. So what we've seen here is actually and again, I like to tell small white lies sometimes that we'll eventually fix in the interest of simplicity. But all this stuff that I've highlighted there's some other stuff that the browser sends back and forth. Some of it's interesting, some of it's not, and we'll tease it apart over the semester. But the juicy one are the two up top. Get /HTTP/1.1. But then the line below it is kind of curious. Notice that the browser also sent sort of a very explicit mention of what? www.cnn.com. And this is actually a very good thing because, as promised earlier, there's 100+ students in the course. All of your websites are going to live at our IP address. And if HTTP just said, get me the default homepage using this protocol, well, whose default homepage? Which of the 100 students in the course? So HTTP also supports, by way of this header, this feature of virtual hosting. Again, kind of a buzzword, but what it means is you can have multiple websites living at the same IP address so long as the browser sends a reminder as to what the URL originally was. So long as we've said CNN.com here, we'll get CNN's homepage. Now, CNN is big enough that they probably don't have like 100 students' websites running on the same servers. So in our context, when you pull up davidnow.me, same IP address, but it goes to my home directory and goes into my public HTML directory and gets those files. But if you go to dannow.me, it's going to go into Dan's folder and get that. And that's because of cooperation between HTTP here and Apache, the web server software, which actually knows to look for this field to figure out what directory's contents to actually serve up. So we will make significant use of this tool over the course of the semester, partly because it's interesting, but partly because it will show you what your own code is sending back and forth across the wire, whether from JavaScript or PHP. So XHTML. The course, though we expect familiarity with HTML, XHTML is essentially a cleaner version of HTML. It means it's an XML derivative, which essentially means if you open a tag, you also closed it, which HTML does not really require. If unfamiliar with this, we'll talk about it during section, but what you'll see the other aspect of Project Zero is to get a simple homepage out there on the internet at your particular domain name and just make sure that the XHTML is valid. And there's a couple of resources on the course's website that say what this means. But again, if you open a tag, you close it. All tags in XHTML have to be lowercase. Any attributes have to have single or double quotes around them. None of this messy HTML approach to life. So as a computer scientist, XHTML is a much prettier language because it can be deterministically parsed. HTML is a mess when it comes to actually parsing it, and that's one of the reasons why websites back in the day really used to render differently in different browsers. Yeah?
Sorry, you said single or double quotes. Do you mean the entire thing needs to be single or double quotes?
Nope. Foo equals quote-unquote bar or quote-unquote bar.
And then the next tag also?
Same pattern. Repeat.
Okay, so the entire document needs to have single quotes, or the entire document needs to have double quotes?
No. Only with respect to each attribute value pair. You just have to be consistent with respect to opening and closing. But then you can use doubles the next. But then you get into matters of style, like why are you alternating or questions like that. But actually, that will happen in code when you're generating things dynamically sometimes. Actually, let me just forge ahead with a couple of things. So CSS. So again, this course really isn't that much about aesthetics, but we'll expect you to use CSS because we'll encourage best practices, and you'll learn some tricks along the way aesthetically. But realize that there's a couple approaches to CSS, and Project Zero will make mention of this. If unfamiliar, CSS really lets you take markup the final mile, where you can kind of lay things out structurally pretty nicely in XHTML, but font sizes are like font size equals 1, 2, 3, 4, 5, 6. What does that even mean? Well, it didn't really mean anything specific back in the day. So CSS lets you say font size equals 12 point or 12 pixels with much greater precision. You can do this by embedding CSS as depicted here right in your web page, or you can also embed it in an external file, which is for various reasons, often better in an external file like this. So we'll discuss both approaches in sections, and you'll see both over time. Validity. What does this mean? Well, XHTML can be two things, so far as we care. Well-formed, which means it adheres to the rules I rattled off before about opening and closing and quoting and all of that. But valid means you're not just making up your own tags. So valid means your code, your XHTML, conforms to the World Wide Web Consortium definition of what XHTML is. So you'll see the very low bar we've set for Project Zero is that, yes, you need a web page, but it's also got to be valid XHTML. We do not care about valid CSS. It's just too hard to get CSS valid across all browsers these days, and it's not an interesting exercise. So just FYI on that. Cross-browser issues. So this is something we will focus on, at least in part, and frankly, you're going to experience it indirectly throughout the semester. It is a big pain, 10 plus years after this stuff got popularized, that we're still battling with slight aesthetic differences and functional differences across browsers, but we'll discuss these over the course of the semester, and websites like this can help, because they can help you see, if you can't run the browsers yourself, what the differences actually are. We'll make good use of libraries throughout the course. So I'll often preach some of Yahoo's YUI libraries, both for CSS and JavaScript. More on those in the weeks to come. But in short, libraries like this, and honestly, just being acquainted with some things like this, really just as an aside, can really simplify development both during and after this course and make it much easier to deal with some of these headaches like cross-browser issues. Among the things it does is if you include a line like this in your XHTML source and say, use Yahoo's CSS files, this reset library is all about resetting the aesthetics across all browsers to some base so that all font sizes by default will be the same, because some really nice people at Yahoo did all the headbanging to figure out what all of the tweaks should be to normalize things like that as it relates to fonts as well. But where we'll launch into at lecture 1, Zero Index, is actually programming stuff in PHP. And the basic UI mechanisms, if unfamiliar or familiar, will really boil down to these simple things. Some text fields, radio buttons, select menus, and so forth. And out of these basic building blocks will come your first dynamic websites. So I'll stick around for a while in the hallway with questions. Otherwise, we'll see you in a couple weeks.